If you're a validator or a staker or generally following Ethereum blockchain and curious to learn about the famous ETH withdrawal proposal and its testing progress, stay with us. Welcome to PEEPanEIP episode 94. I'm Pooja Ranjan. In this Shanghai special episode, today we are going to talk about withdrawal devnet and testing progress with two special guests, Hsiao-Wei and Potuz. Hsiao-Wei is a researcher at Ethereum Foundation, and Potuz is a developer with Ethereum consensus client Prism. You may have seen or heard Potuz on episode 78 on PEEPanEIP talking about the Prism client. If you missed, check out our Know Your Client series at Ethereum Cat Herders YouTube or Ethereum Cat Herders podcast. Thank you, Hsiao-Wei and Potuz, for joining us on PEEPanEIP show.
Thank you for having us.
As to let our viewers and audience know our guests better, may I request you both to provide a quick introduction with a little background and the way to the Ethereum community, maybe starting from Hsiao-Wei, followed by Potuz.
Hello, I'm Hsiao-Wei. I work for Ethereum Foundation Consensus R&D team. So in 2017 that I started to work on the early sharding proof of concept, and then our team work on the Casper FAQ, and then the thing changed fast in the stake vacations. So and then the consensus R&D team also work on the beacon chain, and at the meantime, we also work on all the meaningful, important Ethereum future updates, future upgrades. So that's what I do in our team. And I'm also one of the main consensus layer stake vacation maintainers. So I'm going to give you some introductions of the withdrawal and the testing perspectives today. Thank you for having me.
Thank you, Hsiao-Wei. I had been trying to have you on the show for a very long time. So yeah, thanks once again for joining us today. All right, maybe we can go ahead with the Potuz introduction.
Sure. Mine is going to be quite short. I'm called Potuz. Well, they called me Potuz. I am still a professional mathematician, but I'm switching slowly, or rather, I'm already fully switched to working on the Ethereum core development. I've been working with Prism for over a year now. My earlier work was focused mostly on hashing. Then I moved towards implementing fork choice changes to Prism. And lately, I've been focusing on the Capella implementation only, mostly. After what we went through for the merge, implementing Capella is something very, very much light. There aren't that many people within our team working on Capella because most of the heavy work is now moving towards other areas. But anyway, so Capella, even though it's a light fork, is a fork that is being waited for a long time in the staking community, and we're excited to be delivering it soon. We are at a stage that in just a few weeks, we're going to be opening large testnets for the public to test withdrawals. And it's very exciting that this is just really the conclusion of the merge. You should not consider the merge complete until we actually have access to those funds that have been locked.
Definitely, it makes a lot of sense. Merge was just the beginning. I hope to see Ethereum community growing like this and more validators and staking coming on the network. Well, thank you both for sharing about yourself. Before we dive into today's presentation, let me provide some more context. EIP 4895 beacon chain push withdrawal as operations was selected in April this year to be the way forward for withdrawing staking rewards after a series of discussion on different proposals on withdrawals in client devs meeting early this year. It is recommended to watch PEEPanEIP episode 68, an overview of EIP 4895 with Alex Stokes to have a better understanding of the proposal and definitely following what's going on with it. With that said, I don't want people to be waiting anymore for withdrawal testing updates. So without further ado, let's peep in.
So, okay, so I'll start. And most probably, I'm just going to repeat many of the things that Alex must have said in that episode, because I'm mostly going to concentrate on a high-level overview of what Capella is, mostly from the staking perspective. So, okay, so let's start with this. I am an operator. I've been staking for over 2 years since the BeaconChange launch, and I have, I mean, most stakers now will have over like 7 ETH extra that are not being used for anything. They're not securing the network. They're just sitting there in the BeaconChain, and they would want at least that back. So what do you need to do to get your ETH back? Either if you want just the excess over your 32 ETH, or if you want everything that you've got in, well, you may need to do 2 things. You may need to do nothing. So there are 2 different areas to a withdrawal. One of them is to say, I want my money to this address. This has to be an execution address outside of the BeaconChain. And the other one is, I want all my money, or I just want my excess money. These 2 messages are different, and these 2 messages are signed by different keys. So I want to go over what are those keys, even though most of you would already know this, but anyways, it's not hurtful to go over this again. So the first message, that the one that you need to tell, you may need to send to tell your beacon, I want to have my money in this address, is to send a message that is called a BLSToExecutionChange. That BLSToExecutionChange is a message that is signed with your withdrawal address, and I'll tell you in a second what is that. And if you want all of your money, then you need to exit your validator first. And this is a message that is called a voluntary exit and is signed by the validating key, which is a different key than the withdrawal key. I say that you may need to send these messages, and you may need to exit your validator, but you may not. For example, you may already have an execution address in your validator as a withdrawal address, and you may already have exited your validator. For example, if you were slashed, you already have exited your validator forcefully, but you exited already your validator, and you are going to be withdrawn automatically when Capella happens. So let's talk about keys. This is the lucky first validator that actually proposed the first block in the BeaconChain 2 years ago. And here's one key. You can just look on BeaconChain, on beaconchat.in, and you're going to see this. This is the key that most people would look at in a validator. This is the public validating key. But today, we're going to be mostly interested in a different key, which is the withdrawal key. And the withdrawal key, not even the public key, is available now to anyone. You can see, for example, when you go to the deposit that made this validator. So you can see here in Etherscan, for example, this is the public key, and it's the same public key that I showed for the other validator up there, for the same validator up there. And then the withdrawal credentials is this hex string of 32 bytes. So this withdrawal credential in this case is a hash of the actual public key, the public withdrawal credential, except that the first byte here, and that's the important one, the first byte is changed to be a 0 instead of whatever the hash would have. So this 0 that I see here is a prefix, and this prefix being 0 means that this address is a BLS address and it's not an Ethereum address, a withdrawal credential for this validator. So this validator, for example, if you wanted to exit, or if you wanted, if you wanted to withdraw, will have to send that message saying, hey, I want my money in a different address, because this address that is there is not a valid Ethereum or execution address. Okay, so each validator has two pairs of keys, two pair of public and private keys. One of them is in your validator client and is hot. The validator client has that private key to sign messages. You sign every epoch, you sign an attestation, and from time to time you sign a proposal. And that signature is being done with the validating key. This is a pair of BLS keys. Each one of them is 48 bytes. And the public key is the address of your validator. The withdrawal credentials on the other side, well, they are different kinds of them. I've only shown you one so far. This one that I've shown you is also a BLS pair. If you created your keys with a mnemonic from the stake and deposit key, would have this pair that it hasn't shown it to you, but you have access to that withdrawal key. And it's again just a public and private key. If you have the public key for that one and you hash it and you change, that's going to give you 32 bytes instead of 48. And you change the first byte for a 0, and that's what your withdrawal credentials are. So the withdrawal credentials that are a public facing object of your validator consist of the hash of the withdrawal public key. And it's just changed the first byte for a 0 to signal that it is a BLS key. But there are other validators. For example, Rocket Pool validators would have an Ethereum address already as a withdrawal credential. Since withdrawal credentials were supposed to be these 32 bytes that were given by a hash, but Ethereum addresses consist of 20 bytes, then the way we signal that a withdrawal credential actually mean it's actually an Ethereum address is by putting the first byte to be a 1. So this is going to be called an execution prefix. Then we're going to just fill in with blank zeros. So this is 11 zeros, so that when you add the remaining 20 bytes of your Ethereum address, this is the full withdrawal credentials. So there are some withdrawal credentials of some validators that already are pointing towards an Ethereum address. Here's an example. This is the first validator that is on top is the validator that I showed before. It has a BLS withdrawal credential. But this other validator, this is a validator that is the first validator after the 400,000 mark. And this validator already has an execution withdrawal credential. You can see it here in the withdrawal credential. It starts with a 1. It has 11 0 bytes. And then this Ethereum address that consists of 20 bytes. So this validator, for example, if it were to exit today, then when Capella hits, all of its balance is going to go to this address here in the Ethereum execution chain. All right, so let's talk about now what type of withdrawals we're going to see. Well, all validators that already have an execution address, like the previous one that I've shown you, or all those that already changed their address when Capella, after Capella, you're going to be able to change your address, then you don't need to do anything else. Every once in a while, currently this is going to be every 5 days, more or less, you're going to get everything that you have on excess of 32 ETH to your address. And this is going to be deposited automatically in your execution address. So as soon as you change your address, your withdrawal credential to an execution address, you're set every few days, which is about 5 days, the current beacon chain size, you're going to get your excess balance in that account. If you do not have an execution address, an execution prefix withdrawal credential, you're going to have to change your address if you want to have your excess balance. You can do this whenever you want. You can send this message whenever you want. And you need to send this message that is called a BLSToExecutionChange. So here's such a message. We're using this to test on devnets. This is changing the withdrawal credentials for this validator index number 3 that has a given public BLS key. So these are 48 bytes. And it's changing to this unlikely withdrawal credential, which this execution address, which is this 20 bytes that I just chose them to be 1, ending in 1. And it's just a signed message. The important thing about this, this message is that it's signed with your withdrawal key. Since you can only change addresses from a validator that has a BLS address, then that means that that validator has a pair, has a BLS pair. So it has to have access to the withdrawable private key. And that private key has never been online, hopefully. So you probably want to keep it that way. You really want to sign this message still offline in an air-gapped computer. So let's go to that. We'll need tooling to sign these messages. Most of people that were careful enough did not create their mnemonic in a computer that was connected to the internet. So hopefully their mnemonic was never exposed to the internet. And we want to keep it that way. So no client that I know of, none of the consensus clients that I know of will actually implement any signing feature. So we're going to rely on external tooling. Currently, ETH, which is there is the GitHub, the GitHub, you can just check it, can actually produce currently now these messages, and it can actually broadcast them. That's a feature that I don't want you to use. I want you to use the feature of signing your messages offline in an air-gapped computer so that your mnemonic is never exposed. We expect to have the Hsiao-Wei just told me that it was her homework for the holidays, that we expect to have staking deposit key from the Ethereum Foundation having this functionality soon. So at least we have two different toolings to sign these messages. Once you have this message signed in an air-gapped computer, you can actually just transfer this message to your online validating computer and broadcast it for the world to see. So that's a possible workflow. You just boot up your laptop with a pen drive on Tails OS or whatever, depends on your level of paranoia. You run your tooling to generate this message and sign it with your private key. If you have access to your mnemonic, the tooling would actually, you're going to say, I want to withdraw validator number 3 that I created with this mnemonic. Then tooling would know which private key to use and would just generate with the BLS change for that validator. Once you have that change, you can just go to your client, and here client might choose to implement a particular command to assist you. All clients would just take a simple curl, which is here. That's exactly a command that we're using. Prism, for example, already has a PR open to actually have an actual command that would take your file and assist you, like making sure that you want to exit this validator, tell you this is the address that you're sending, this is a checksum address or not. So just add some, just take some extra safeguards to prevent you from sending the wrong message. I think Lighthouse and Teku are thinking about doing the same. I haven't heard back from other clients to whether or not they're going to have this functionality, but it's not really necessarily a simple call would just send you the file if you were careful enough offline signing this message. All right, so the other kind of withdrawals that are there, not the ones that are partial, everything that is in excess of 32 ETH, is if you want everything back. If you want all of your money that you have on the Beacon chain, well, then you need to exit your validator. And the funny thing about exiting your validator is that this is signed with a different key. This is signed with a key that is already hot in your validator client. So all clients already can sign and submit this for you. So this is the command that you would use if you're using Prism, and similar commands if you're using a different consensus layer client. It'll let you choose which validator you want to exit, and you just exit your validator. If your validator already has an execution address, then your validator, whenever its turn is, it's going to completely withdraw. And it's going to give you everything that you have in your BLS address, in your execution address. If you have a BLS address, then you're going to have to change that address. And you can do this before you exited, after you exited, at the time that you're exiting. At any time, you can just send that message. So it's fine if you've already been slashed, you still can withdraw. Okay. As I said before, with the current beacon size, it'll take about 5 days since you change your address to be withdrawn, assuming that you're already exited. All right, so let's get slightly more technical as to how withdrawals happen. Here, this is the point of view of the proposal. Okay, so withdrawals are messages that are going to be included in blocks. And the way they are going to happen is as follows. The proposer of a slot, so a proposer in slot n+1 knows that it's going to propose in the next slot. So during slot n, is going to ask its execution layer to prepare a block. And in that message, when the consensus layer client using the engine app, it sends the engine API, sends the message to the execution layer to prepare the block, it sends them the full list of withdrawals that should go in that block. So the proposer just queries its beacon, it gets a list of withdrawals, it grabs this list of withdrawals, sends it to the execution layer one slot before it's actually proposing. The execution layer would grab these proposals, pack transactions from users into an execution block, it will prepare that block and send it back to the proposer. So when the proposer is in his slot in n+1, the proposer would just query for the a full payload from the execution layer. The execution layer would send the payload back with the exact withdrawals, the same withdrawals that the proposer sent before. And the proposer just signs and submit the block for everyone. So now what happens on the validator side? This block went through the network and then validators grab this block and they need to attest to it and check how withdrawals are actually enforced. So now validators would get this block with the withdrawals. And the first thing a validator does is send the execution payload, what we used to call block in the PO area, to the execution layer. And the execution layer grabs the list of withdrawals within that block. The execution layer then just sees each withdrawal and mints ETH to each of the addresses that are listed in those withdrawals. I'll show you in a bit how a withdrawal message looks like, but it contains an address to give ETH and it contains an amount on how much ETH needs to go to that address. So this is minted in the execution layer. And then the execution layer checks the validity of the block. It sends back to the consensus layer saying, this block was valid from my perspective. And only then the consensus layer client, the validator, processes the block and says, okay, so now I have the list of withdrawals, and what I'm going to do is burn the exact amount that was already credited on the execution layer on the beacon chain. So we are minting ETH on the execution layer and burning it on the consensus layer on the beacon chain. This is the withdrawal message. It contains an index. This is just the withdrawal index is just to keep an account, and this is a monotonically increasing index. It's going to start at 0 and it's going to increase by 1 and each withdrawal that we see, so our clients can check that it's sequential. It's going to have a validator index indicating the validator that is actually withdrawing. It's going to have an address, which is an execution address. This is a 20-byte address that is going to be credited an amount, and an amount that is going to be credited in that address. Again, I am a consensus layer developer, so amounts for me are in Wei. This is how the message looks for a consensus layer client. On the execution side, the amount is going to be in Wei, which is 10 to the 9 Wei, and it's going to be credited in Wei on the execution layer. The Wei, there was something that was essential in the previous slide, that the proposer asked its beacon the slot before, give me the withdrawals. And then the validator during the next slot, when he got the block, asked its beacon, give me the withdrawals that I expected in this block to see if they are the same. So that means that withdrawals are something that the beacon chain knows and is completely deterministic. And the way we achieve that is by sweeping. We're going to start at validator 0 and just start looking which validator can actually withdraw. And we're going to find the first 16 of them and just give them back. We're not going to sweep forever. If we sweep for 16,384 validators and we haven't found we haven't found the 16 withdrawal validators that is the maximum that can be included in a block, then we're just going to stop there and just send back whatever we have. Now, what does it mean that a validator is withdrawable here? Well, if you have more than 32 ETH and you have an execution address that I can send you money, then you are withdrawable and you're going to execute a partial withdrawal, except in one case, which is the case that you can actually perform a full withdrawal. And this happens when you have any balance in your validator that is non-zero, and you have already exited your validator and already went through the queue to actually be withdrawable. So validators that have exited for some time and have any balance in them, they're going to get their balance in their execution address. If you exited, however, and you don't have an execution address, well, you're going to be staying there with your balance there until you change your address to an execution address. Okay, from the execution layer perspective, withdrawals are very simple. They get the block with the list of withdrawals. There are messages very similar to what I just shown you in the previous slide. They know the route that as a safeguard of what are these withdrawals. Withdrawals are not usual transactions. They are system level operations. They do not carry any gas cost, and they are only performed after so the execution layer gets a block. It syncs all transactions from users. It adjusts the state, and then after doing all of this, it just carries the withdrawals. It means ETH to each one of the withdrawals in the list. Withdrawals can never revert. They can never fail. They will mint ETH to those addresses, and they're not allowed to fail. And yes, as I said, they are processed after all user level transactions. Here are some interesting cases. Hsiao-Wei is going to be talking certainly about this, I suppose. But this is just to give you an idea of like all of the possible consensus breaks, all of the possible consensus problems that we may have because of these edge cases. Slash validators can change their messages, and exited validators can send these messages to change addresses. Fully withdrawn validators, so you already exited your validator, you're fully withdrawn, you're fully withdrawable, the sweep passes by you and it gives you all of your balance. And then circumstances is that you can still get money in the beacon chain. For example, you can exit your validator while being in a sync committee. And if you're still in a sync committee and your validator is still active, even though it's exited, it can sign messages for the sync committee. It can actually get some ETH on the beacon chain, even though it's already withdrawn everything. So in the next sweep, it's going to give you a few way more. And it's going to be an extra full withdrawal. Another way of performing several full withdrawals on the same validator is just by depositing more. If you have a validator that is already withdrawn and you decide to deposit more money in that, that's fully allowed. We're going to just give you your deposit in the beacon chain, and the next sweep, you're going to withdraw it again. There's some use case into signing messages before the Capella fork happens. If your key was stolen, for example, there are several cases of people that are advocating to have some KYC kind of system to try to prove that your key was hacked, that your withdrawal key, that your mnemonic was exposed. Then you're going to be racing against hackers to have your change address included in a block before them. And clients are going to implement, I'm hoping that clients are going to implement this. Prism already has this. And I think I talked to Lighthouse that we're going to do this. I suspect all clients are going to have one way or another of doing this, of allowing your message to be in their pool, in the operation pool before the Capella fork happens, so that you can have large staking pools having whitelisted changes of addresses of people that they already know or people that they think they know and they have proven somehow that their withdrawal credentials were stolen, so that they are included in blocks earlier. This message can be signed now. They are technically hard now because tooling is at an early stage, but we're hoping the tooling is going to get to a point that it's very easy to sign these messages before the Capella fork happens. So currently, if you want to, I can tell you later how to sign them for with ETH, for example, with ETH2, I'm sorry. for example, but you're going to need some extra information like the fork version, the Genesis validator roots, and a bunch of fields that are needed to sign these messages before the Capella fork happens. All right, so let me just quickly tell you what is going on devnets, and this is my last slide. I'm just going to pass this to Hsiao-Wei. We tested very early, about a month ago already, most of the features on the consensus layer side. We tested a month ago 4 consensus layer clients, all of them but Nimbus, if I'm not wrong, and 2 execution layer clients, Get and Nethermind. And we checked everything except the P2P stack, which is a non-trivial part of it. So we didn't check that you could actually broadcast BLX to execution changes. We could include them in blocks, change your address, and people would take the block and process the BLS to execution change and change the address. And withdrawals were working fine. We found some interesting consensus bugs. Prism had a bug about what I just told you in the previous slide, that a validator that could withdraw several times by being in a sync committee. There was some freak case. If you were in a sync committee multiple times, Prism will fork off. After those early devnets, we were in trouble because Prism could not start on a devnet on a post-merge state, and Bezu could not fork. So it could not start from phase 0 and fork into Capella. The Capella fork is different for an execution layer perspective because it's going to be a fork on a timestamp base instead of on a block base. And this is something that wasn't implemented in Bezu at the time. So we couldn't test Bezu and Prism at the same time. So we had Barnabas, a huge shout out to Barnabas, a new hire of the Ethereum Foundation, and he's been taking care of the devnets for all of us. And he was running 2 sets of devnets, one with Bezu included, one with Prism included. One was starting after the merge, the other one was started before the merge. Now Casey, one of our teammates, implemented a PR in Prism to actually be able to start Prism from a merge state. Now we can test all clients together. Nimbus already joined the devnets, and we're all working. I believe Aragon is the only client that is missing on those devnets. And we're fully featured, or almost fully featured, completely fully featured on the consensus layer side. We can submit and broadcast BLS changes. We are gossiping them. We are withdrawing full withdrawals, partial withdrawals. And also on the execution side, there are other changes besides withdrawals on Capella. Well, Shanghai is going to have EOF, and well, I presume other people who are more capable than me are going to talk about these changes. But these changes are already being tested, and I think most of them are already included. There are some things that are extra features. For example, we are going to have the block value that a proposer is expected to get when proposing a block, so something like the bid, something to compare against the bid from a builder if you're using MEP Boost. And this is a nice feature to have. We're going to have these clients already testing this on Capella, because it's going to allow us to switch to a local execution if our local execution node is paying us more to propose a block. Or if it's paying us some threshold more than some threshold less than what the builder does. So this is going to be useful as mitigation for censoring, because if you have a transaction that is being censored by the builder that is trying to get in and is increasing the tip that is paying, eventually it's going to get in because clients are going to just fall back to execution, to the local execution node, instead of allowing them to use MEP Boost on a builder that is censoring. As I said, a huge shout out to Barnabas that is taking care of the devnets. It's been carrying the load of dealing with a huge number of combination of clients. We have currently testing 5 consensus layer clients and 3 execution layer clients. That's a non-trivial task to do on devnets that are jumping every week. We're changing them. All right, so I think I'll just stop my share here. and I'll let Hsiao-Wei take over.
Thank you, Potuz. Let me share my screen. Okay. Okay, so this is the agenda today, and so Potuz has covered the first part, the withdrawal functionality introductions. So now I'm going to introduce to talk about what it is from the perspective of Validator. So to describe the status of a validator, there are mainly 4 stages here. First is that if the validator made a deposit message and this message has been included to the beacon chain, but now it will create a new entry in the validator registry. But at the first stage, the validator hasn't been activated yet. And the next stage is the activated. So if a validator is activated, then we say that this validator has the validator duties, and they have the responsibility to validate and send their attestation message to the beacon chain network, and they have to propose the block, etc. Then, so I think one thing that I want to note to you is that there's a rate limited when we are handle the validator set update. So this is for both the security and the performance considerations, that there's a rate limited here. The churn rate is based on how many active validators in the beacon chain at the moment. So yeah, so once it's activated, they have to perform like all the active validators are doing right now. And the next stage here is the exited. So validator might initiate the voluntary exit, or they may get forced exit. So the activated and exit, both stages are they have the same rate, which is calculated by the beacon state transition in protocol. So after noted that after the exit, then we have the last stage, which is the withdrawable. So the validator, they have to get to the withdrawable stage so that they can perform the fully withdrawal in protocol. So, and should I start to see any questions? There rate limit to send BLS change credential message on beacon chain. Yes, it is also in protocol in the preset configuration. We'll also talk about it later. And then next, let's see the full validator life cycle. I mean, all this on the right hand side is a very detailed state transition flow here, and I think we can just mention that main point is that about the exit, there are 2 approach. One is like I said before, the voluntary exit. So the validator, they can initiate this spatial voluntary exit message to quit from their validator duty. So here Yeah, I guess not sure if it's too small to see, but there's on the approach 3.C1 is the voluntary exit message approach. And another possibility is that the validator might get slashed. So after they get slashed because they had sent the malicious attestations like the double vote or the double proposed block, then they will get slashed. In this case, the validator also will get forced to exit in protocol. And the third possibility is that the validator might, due to the leaking, like they didn't perform with their attester duty for a while, then they will be leaking their balances. So in that case, if their effective balance is less than 32 Ether, then in this case, the protocol will also detect that if the validator has efficient balance, then they will eject it in protocol. So these three possibles that will get you into the exited stage. So I believe that most active validators are going to use the first approach, which is the voluntary exit, but also note that with this withdrawal features, then we will kind of rescue the slashed validators. Because like in the current beacon state, there are still not many, but just a few validators, they unfortunately got slashed, and then like their bands kind of are stuck on the beacon chain at the moment. Yeah, so, and if you want to learn more the full details of the life cycle, you can see the reference and to the detailed explainers. And I also prepare some FAQs for the validator and the staker here. Based on the previous presentations. So I think people might have some question like what the Q1 is, that what kind of the address that I can use in this BLSToExecutionChange message. So you can use EOA or a contract address, just if it's any address that if it's a valid EVM address account. So this execution address is the 20 bytes Ethereum address format. And the second question here is like how long it takes to change my withdrawal credential to execution address format. So yeah, and like Potuz talk about how it can, if the possibility of how to let the staking pool to include this message as soon as possible. But even if it's included, there's also the red limit here. Benjamin asked it in the chat, like each beacon block can include at most 16 BLSToExecutionChange messages. But if that said, but we will do the devnet stress test later. So based on that result, then we might change this preset. It could be increase or decrease. The third question is, can I change my execution address again after I have applied my BLSToExecutionChange message? So unfortunately, there's no interface to allow users to do that. So please make sure that your BLSToExecutionChange message is correct and double check the address again before you send it. And okay, one more question. If not including the first bar, will it be required to keep limit to the gossip message? I will leave it to Potuz later. And the fourth question is like, so if I am an active validator, how long it takes from activated to withdrawable status? So there are like 3 different time that we have to combine together. The first factor is the time that one validator to include your voluntary exceed message in the beacon chain. So each beacon block can include at most 16 this voluntary exceed message. Yeah, it's the same as the BLSToExecutionChange message limited. So and so that it will be included. There's also the time to wait in the exceed queue. So even if there's no other queuing validators that in front of you, there's also a delay of like 4 epochs. So you have to, if there's no other validator behind you, there's still this delay because we don't want to. This delay is because if the validator get slashed, if like one validator can exceed voluntary exceed, and then during the time after after their exceed message got included, they could still perform malicious behavior after it. So this cooldown period is for protect that, to make sure that validator will their bans might be considered in the slash message penalties. And then so if we calculate this churn rate with the current like 490K active validators, the churn rate is about 7.4 validators per epoch. So you can calculate that from these parameters to see how long it takes for you to be withdrawable validator. And the last part is the delay from exceeded to withdrawable. This is also the this is for the slash validator consideration. I mistook to stage. And think the point is that you have to make sure that your validator has fully exited before you turn off your node from here. Sorry, it was a bit miss. The next question is like, how long it takes to get my partial and full withdrawal that I have set after I have set up my withdrawal execution stress. So there's another preset called the max withdrawals per payload. So the current value is also set to 16 withdrawals per block. So with the current size of the validator state, we will get like 102 hours per cycle. So it will, if you are waiting, depending on your, you are waiting for getting the partial withdrawal, it might take that long time to get your turn to be paid in on-chain. But also this number could be changed because the sweep that Potuz mentioned before. So there's a case if it's possible that there's no previous validators are eligible to perform the partial withdrawal, then this number will change in that case. And also, as before, that this kind of presets might be changed when we see the devnets stress test later. Okay. And the last question is that people want to ask like, when can I withdraw on the mainnet? So the previous Codex core has decided that this feature will must be included in the next protocol upgrades for sure. And the spec size that is nearing completion. So now everything is just how to make sure that the software is fully we are fully comfortable to deliver it. So just test. So I would say soon next year. Okay, then any question before we talk about the progress and the testing? No. Okay, thank you. And there's the list of the specs that will be changed for the withdrawal features. We have the consensus layer and the execution layer. By the way, the consensus layer fork is called Capella, and the execution layer fork is called the Shanghai fork. And also, beside that, we have three main API interfaces, which is the engine API and beacon API and builder APIs. You can see it from the diagram here. So on the left-hand side, it's the CL, the consensus layer components, and the right-hand side is the execution layer components. So the beacon node and validator client are communicated through the beacon APIs, and the beacon node and execution engine are communicated through the engine APIs. So, and both the beacon node has its own P2P network, and the execution engine also has their own P2P network. So since we are going to add a field to the beacon state, and we will also add a field to the execution payload. So all these components has some interface updates for sure. So we have to test all the modules. And there are mainly 5 different approaches to test withdrawals. Maybe not only withdrawal, but all the future Ethereum protocol upgrades will go through these 5 different approaches. So the first one is the static test vectors. So the client teams, they have their own unit test, and for the spec side, we have the spec test vectors. And I am one of the maintainers of the CL Pyspec, so I will talk about it in deep later. And the second part is the fuzzing test. So we have the fuzzing test is to test the components against the random data. So Mario's from Go Ethereum Gas team, he maintains some fuzzers to test the EVM and engine API. So these are the main fuzzing tests we have in the Ethereum client teams. And the third one is the end-to-end test. So in this part of the main testing module is the hype test. So it is end-to-end test to simulate one of the components in the test. For example, if you can simulate the engine API, so you can simulate the engine API to talk with the CL clients and to talk to the EL clients in the test. And this is very interesting testing suite that we had before the merge. So the testings, kudos to the Ethereum Foundation testing team. They provide this very good testing platform for us. And now after the merge, we have like 5 CL clients and at least 6 EL clients. So that leads to like 30 different combinations only for the client. So the end-to-end test is very important for not just the Ethereum protocol upgrade, but also since we want the client diversity to be improved, then these tests are required for us. And the fourth component, which is what the client teams are currently working on, is the devnets. So there will be the short-term validator testnets to test the stress test and to try the different while we are stabilize the specifications. The devnet is very important to find the edge case in real life. And the last part would be the public testnets. So once we get this stage, there will be the public testnet for the stakers and to try it out on like the Gali or other public testnet that you already know, or there will be a new public test only for withdrawal in this stage. Okay. Any other thing I missed? No. Okay. We are a bit out of time. I will speed up. So I'd like to talk more about the CL execution executable Pyspec because that's what I'm working on mainly. And so the Pyspec is like, it's a repository of spec, and it's a collection of the core consensus applications. So it all the core consensus protocol logic is defined in this markdown files. And also this repository is a Python repository. It's executable and verifiable. It can be built into a program and could be to be executed with the spec. And the third is that it's a test vector generator, and to provide a static test for the clients to use. This is an example of how we write a Pyspec test here. So you can see that we have the basic spec. If could you see my mouse? I think so. Oh, you can. The spec is like it's a Python module here. So it could be like base 0 or Altair, Bellatrix, or Capella specs. And also we have the pre-state here. So we would do something with the to generate a valid pre-state here. And then we use the Python YAL to convert the state. The state is a XSE container, so it can be it could be serialized and compressed into the snappy XSE file here in this line. And then we do something to generate a testing block in the following steps. So we say that, okay, we want to apply this side block to the pre-state here. And what we will get is the post-state because there's a state transition function here. So yeah, that's basically how and what the client team will get. They will get the pre-state, the post-state, and the block that we apply to the state transition functions. So after this, after we run, after this test generator produce the test vectors, client teams will get the on the right hand side the test vector results. So you can see in this example, we have the pre-XSE snappy file and the post state and also the blocks. So that's the main approach that we use to test the to make sure that at least for the basic logic, all the CL client teams are running the same way, that process the block state in the same way here. Okay, so during the withdrawal test writing, I think so compared to the merge, Capella is it's much more simpler than the merge. And this I would say there are three main consider points when we are writing the test against. One is if we can validate the basic verification of the new message. So in this case is the signed BLSToExecutionChange message. And the second is if actually recent rise by Potuz and Aaron's from presenting that it is also important to test the order of the balance operating calculations, because we have like different state transition functions. I mean the different sub functions in the state transition that could change the balance updates. For example, from the deposit to withdraw and all the rewards and penalty updates. So this is important to make sure that the client teams all the implementations are calculated correctly. And the third case is the edge case of the boundaries. So in the Capella test, we have 3 new presets. So all of them are the max value of the new message like that. So it's important to test if the boundary of this message exceeds or is too small to, I mean, just have to test if the message and the limitation in the edge cases. Okay. I think there are more other edge cases that I didn't cover here, but that's the test cases today. And now I think we can move to discussions or other things that Potuz, if you want to add or.
Great work done on testing and for the wonderful presentation. I know testing anything before putting into the mainnet is important for software development, but I'm always carried away by the extent Ethereum team put into testing part. I think adding technical aspects from Potuz slides and FAQ from Hsiao-Wei slide were a plus. Thank you for sharing with us. I see we already have received a few questions in chat. So yeah, opening the floor for questions from audience. If the author can maybe read the question and point towards the guest.
Hey, thanks for a great presentation to both. My main question was around the rate limiting of messages, specifically the BLS change credential operation. I see that there's a rate limit of only 16 operations per block, but if there's many different gossip messages, is there any rate limit to the actual gossip messages? Thanks again for the presentations.
So I can take that one because we were discussing this not long ago. There's no limiting currently on the gossip network. So you can just send, and we can be flooded with these messages. We don't really know. We don't believe it's a worry that we should have. These are signed messages. So it's not that you can actually flood us with invalid messages because they're not going to continue on the network. However, we will test against this as a DOS vector on devnets. As to your question, I think it was related to this, the question about whether or not you can, if you're gonna see a message and that you've seen before, if it has to be included. Was it your question?
Yes, that was another question. So if you did mention in your presentation that it is some clients at least allow the committing a BLS change credential operation early, if that client has already committed it, will they proceed to re-gossip it if you submit it again? And how do you ensure that you're still transmitting that gossip?
Yeah, so there are a couple of things here. So what I mentioned that some clients might implement, and I think they will, is allowing them to input these pre-signed messages into their operation pool before the fork actually happens. So we're not going to broadcast those messages because you cannot broadcast those messages until the fork happens. So there's not going to be any gossip network before the fork. But the question is whether or not those messages are going to be already in the pool. And by having this message already in the pool, then you know that these messages are going to be starting to being broadcasted immediately at the fork. Also, if those validators that are being served by this beacon include blocks, they're going to include those messages earlier than anything else. And the third one, that is the important one for the security of those people that got their keys hacked, is that no validator would actually input and take a new one, a new message from a validator that was already seen. So if you have a message that was already seen, so if you receive a message on gossip that you've already seen, or if you have already in your pool, you're just not going to broadcast that message again, and you're not going to include it in your pool.
Great, thank you so much.
All right, I have a few more questions that we have collected earlier. These are very basic questions for general understanding of people. So my first question is related to withdrawal, obviously, full or partial. We know that there are over 490,000 validators, and we have over 16.6 million ETH staked on Ethereum blockchain. My question is from Hsiao-Wei's slide. It was mentioned the way of validator exiting condition in the validator's life cycle. So if a validator is kicked out or force exited, how will he claim the remaining ETH, which I assume be less than 32 ETH, will get pushed along with the exit?
So after they exit, then they will be withdrawable. Then in that stage, they can initiate the BLSToExecutionChange if they happen to. They might already did before, and since then the process withdrawal will be automatically performed in the protocol. So each epoch will perform. Sorry, not epoch. Each block, then we will perform the process withdrawal. Then we will go in that function. They will go through the validator registry field. So to check each validator. Not each. Maybe there is a sweep here that we will check like thousands of validators to check if they are valid. So with this for loop, then it will be your turn to get a fully withdrawal. I think that's the answer here.
Yeah, that makes sense. Thank you for that. My next question is about change the withdrawal credential address. If I understand correctly, it has to be done by an individual validator. So from Potuz slides, withdrawal is a system level operation and cannot be reverted, as you mentioned. And definitely we would like to minimize errors on creating transaction or signing the withdrawal message. I wonder if there is any provision to validate the withdrawal address before executing. I'm taking it from the context of some facilities provided by Safe like Gnosis, like if you add a wrong address, there's a pointer and we can't do anything about it. So do you think it has to be done on wallet level or individual service provider level, or can it be done on protocol level?
I don't think the protocol that we can actually do this at the protocol level. There's no way of validating that an address is valid or not. We can check for balance, for example, or not. But this can be done at the client level. For example, some mitigations are: is it checksummed? For example, is it the right? You have addresses that you can type certain characters capitalized and certain characters not. And this gives you a way of checksumming for like mistakes in just copy pasting, for example. And clients, before they submit the message, can actually check this. They can actually ask you a question like, wait, with a big sign, are you sure you want to send to this address? This address, is it yours or not? We have already implemented this within Prism, and I think other clients are going to follow through with similar designs. I am not really sure if there's, I mean, I'm open. If anyone opens an issue on the Prism side, we're going to be happy to take it. I'm not really sure we can actually make more of a change like this. This is one of the problems of blockchain, that one mistake is your key, is your money, but one mistake and you no longer have the keys and you no longer have your money.
Understood. It's always a gray area. People needs to be double, triple sure before adding a wallet address, but still having some security check in place either by client or any service provider definitely help novice users to get through it. My next question is related to Hive testing roadmap. So the withdrawal flow was one of the main point of discussion for developers before 4895. So when we reached consensus that it will be 4895, that means we'll be using the push withdrawal, which introduces the system level operation. I understand that it has become more of a CL centric proposal. But I'll be curious to understand about the changes done on the engine API side, because 4895 requests some. The Hive testing document mentioned engine API execution client test suite. Would you be maybe on high level summarize the testing results with changes on the engine API? And another question with it is like, has it been implemented in each client?
Do you want to take the Hive part, Hsiao-Wei?
I'm not sure, so please correct me if I said something wrong. So, like I said, that there's the new field is added to the execution payload. So the execution there, if once they get that message, they will have to do something else. But since this is the push approach, so the engine API seems pretty clean to me. I mean, not much changes there. Is that correct, Potuz?
Yeah. So I think it's absolutely correct that the changes are minimal, but I can provide some nuance as to what are the kind of problems that we have been seeing on our early testing. So the endpoints are changed in such a way that now, well, they would expect, for example, the list of withdrawals, and there's a new version for the endpoints. So if one of them is, for example, notify for choice update. So in that message, when you're sending payload attributes, because you're proposing in the next block, as I explained in one of my slides, you need to send the list of withdrawals. And there's a new version for that endpoint that would take the list of withdrawals. And the old version, of course, doesn't accept it. But then there's a failure mode in which if you're before the Capella fork and you send withdrawals, then that's an invalid payload. That's an invalid code. And if you're after the Capella fork, and even if there are no withdrawals, you need to send an empty list instead of like no field withdrawals. So there's these two endpoints. They're backwards compatible in the sense that I can start calling the new endpoint without any withdrawal list before the fork. And the consensus layer client can actually start doing that. If you already updated your execution client, I can start calling the new endpoint before the fork without any withdrawal list. And at the fork, I'm going to start sending the list. That's one of the things that we could do. Prism decided to do something different. I think each client is going to decide to do something different. So Prism is going to not use the new endpoint, thus allowing our clients to change their execution layer client whenever they want, but as long as they do it before the fork. So we're going to just use the previous endpoint right up to the moment of the fork, and then at the fork start using the new endpoint. This has some advantages that you can just update your execution client few minutes before the fork, but it has a big disadvantage that you're not going to know that you're not updated right up to the fork. So if you forgot to update your client, and you might have updated Prism, but not, say, Nethermind, then you're going to find out that you're not working right after Capella instead of before. These are just design decisions. But this is one of the issues with the execution engine changes, the engine API changes. There are some other failure modes. As I mentioned, one of them is the fact that clients now return the block value, and Prism would just, for example, fail. If Prism is expecting the block value at Capella and it doesn't get it, Prism would just fail. It will not accept that block as valid. Lighthouse, for example, would just ignore it currently. So there are different failure modes for different clients, but this is going to be tested on Hive to see that at least we all fail in this without breaking consensus.
That makes a lot of sense. So yeah, it is very important the client combination people are using, they should be aware of like its latest version, keep it updated all the time, and make sure that it is all ready before the upgrade time on the mainnet.
I'm just sorry to interrupt, but one part of your question was an answer, which is whether or not it was already implemented.
Yes,
and
in
this
clients.
Right. So this is mostly for the execution client, not the consensus client, of course. And as far as I know, I've only been in touch with Nethermind and Geth, and both of them have implemented everything that we needed from the engine API. So both of them have implemented block value. Both of them have implemented the right behavior and the withdrawals. And this is already implemented. I think Bezu already has everything, but there was one of the Shanghai property, one of the Shanghai, not related to the engine API. So Bezu, I think, is feature complete from our perspective. And I think Ethereum JS, which I didn't mention in my slides, but Ethereum JS also was working fine with engine API. I do not know about other clients.
That is good to know, because I could not find information about the implementation in execution specs at EL level. Maybe we need to update the chart. Very well. I have a couple of more concluding questions. Do we expect more testing? Obviously, I remember you mentioned about a few weeks of testing left there. How far we are from the launch of a public testnet?
Okay, I see Hsiao-Wei is still muted. I do not know how to answer that question. There was a small impromptu poll in the Discord R&D, and client devs voted not to have a public testing now, mostly because there are many people going on holidays and things will break for sure. There are some other reasons why not to have a public testnet right now. One of them is that tooling is not ready. We have one tool, which is ETH, but the staking CLI is not working yet to sign messages. So I would suspect that we would want to have that ready before going public. So I can give you a hard deadline, which is by there's a meeting by the end of January where both consensus and execution clients devs are going to meet, and even some people from other areas and research as well are going to meet. And the idea is that have everything feature complete by then, and by then have at least a big shadow fork and a big public testnet ready. So I would say that by the end of January is sort of like it's a hard deadline to have everything ready. Early February to have a big public testnet. It may happen before, but I wouldn't expect it too long before.
Yeah,
that's quite helpful. Yeah, please go ahead.
I just want to add that there's still like one or two small features that might be included to Capella, and so I think that would be decided in January as well, so that we can say that, okay, the spec is finally frozen.
Sounds good. So my last question is, where can people follow more info on testing updates?
I think that the Discord is R&D Discord. There's a testing channels, interrupt and testing channels, and I think once we have the public testnet, and of course we need the public participate to join the testnet. Yeah. And Potuz, you want to add something?
No, that's absolutely perfect. So the canonical place to look is the interrupt channel on the Ethereum RNG Discord. I would say that when the time comes for the public devnets, clients should have documentation ready as to how to test. Each consensus client and each execution client should have documentation ready. And I would ask people to start looking into those documentation. Prism should be ready soon to pinpoint mistakes or things that are not clear. That's really useful. Even if you're not testing, just reading through our docs and saying, hey, dude, I don't understand this. Can you change this? Just flag it in the docs. That's very useful for us.
That's great. And I'm also hoping that there would be an EF blog post explaining the process of participation, or maybe pointing towards the repository and right places to follow. All right, it's time to wrap up. Since the launch of Ethereum Beacon Chain, the community is curious to know when one will be able to withdraw rewards from staking on Ethereum blockchain. Hopefully, the release of this episode will provide answers to people waiting for withdrawal, and we see a decent number of community participation when withdrawal is available for public testnet. Hsiao-Wei and Potuz, appreciate you taking out time sharing the testnet progress. Thanks to all other participants of the call for joining. I hope you received answers to your questions as well. On this note, thanks to everyone watching or listening to the Shanghai special episode. Should you have any questions, let us know in the form available in description or leave a comment. Reach us at ETH Cat Herders Discord. Check out description for links to useful resources and guest Twitter to follow. We'll be back with another interesting proposal overview soon. Till then, keep watching, keep sharing your love with Ethereum Cat Herders. Cheers.